Yes, in this video, let us continue the problems which we discussed so far are about correlation and try to remember these formulae. The ratio of explained variation to the total variation is R square, which is called coefficient of determination, and the coefficient of non-determination is the ratio of unexplained variation to the total variation. And the 50% confidence limits of R are R plus or minus probable error of R, and this is the 68.26 percentage, 1 sigma limits for R, and this is the 3 sigma limit, also called this 99.73 percentage confidence limits. Okay, fine. Let us come to the problems. If explained variation is 20 and unexplained variation is 40, find R square. See, the total variation is explained variation plus unexplained variation, which is 60. So R square is explained variation divided by total variation. So explained variation is 20 divided by 60. The answer is 1 by 3, option D. If unexplained variation is 60 and total variation is 100, what is the coefficient of determination? See, unexplained variation is 60. So, explained variation is total variation minus 60, that is 40. So, coefficient of determination is explained variation by total variation. Explained variation is 40, total is 100. So, the answer is 0.40, option B. Okay. Now, if x plus y is equal to r equal to 5, what is r? Is it perfectly positive or perfectly negative? Right? What is r? R is equal to, the question should be, the correlation is perfectly positive or perfectly negative. See, x plus y is equal to, right? So it says x is equal to 5 minus y. So when x increases, y decreases. So here you have a linear relationship, but the variables are negatively correlated. Answer is option B. Okay. Now, if x minus y is equal to 20, x is equal to 20 plus y. If x increases, y also increases, right? So, the correlation is perfectly positive. Since you have a linear relation, it is not simply positive, it is perfectly positive, okay? Now, if R is 0.6, what percentage of variance of the dependent variable is explained by the independent variable? The percentage of variance explained by variance of the dependent variable explained by the independent variable is nothing but coefficient of determination, right? R square. So R square is 0.36. But the percentage, you have to give the answer in percentage. It means that it is 36 percentage. So the answer is C. 0.36 into 100 is 36. Okay. So coefficient of determination is actually asked here. Next. What is the ratio of explained variation to total variation? Explained variation to total variation is R square, which is called coefficient of determination. So the answer is C. Okay, coefficient of determination. If R is equal to 0, what is probable error of R? Probable error of R is 0.6745 into 1 minus R square by square root of n. When R is 0, this term will go. So you will have 0.6745 divided by square root of n. The answer is option A. If R is equal to 1, what is probable error of R? If R is equal to 1, 0.6745 into 1 minus R square by square root of n. This term goes off. So 0 into anything is 0. So probable error is 0. The answer is option B. Okay. If standard error of R is equal to 0, what is probable error of R? Probable error of R is 0.6745 into 1 minus R square by square root of n. This term is actually standard error of R. Okay. So if that standard error of R is 0, the probable error of R is also equal to 0. Okay, 0, the option, sorry, this 0. So the option A is the right answer. Now 50% confidence limits for the population correlation coefficient is R plus or minus probable error of R. Option A. If R is equal to 1, which of the following is true? Then R square is equal to 1. What is R square? It is explained variation by total variation, right? So if R square equal to 1, then it means explained variation is equal to total variation. So B is correct. Okay, option B is correct. Next, if R is equal to 1, unexplained variation is equal to what? R is equal to 1 implies R square equal to 1 implies explained variation by total variation is equal to 1, which implies explained variation is equal to total variation. Okay, now you need unexplained variation. Unexplained variation plus explained variation is equal to total variation, right? So these two are equal, so they go off. So unexplained variation is equal to 0. Answer is option B, right? Unexplained variation plus explained variation is total variation. These two are equal, so you have unexplained variation is equal to 0. If R is equal to 0, what is explained variation? R is equal to 0 implies R square equal to 0, and that implies explained variation by total variation is equal to 0, which implies explained variation is equal to 0. Okay, the answer is option B. If R is equal to 0.8, what is the ratio of explained variation to the total variation? The ratio of explained variation to the total variation is called coefficient of determination, which is equal to what? R square. So the answer is 0.8 square. 0.8 square, that is equal to 0.64. Answer is option C. Okay. Now the next question. If R is equal to 0.9, the coefficient of determination is 0.9 square, which is 0.81. Right? R square is equal to 0.9 square, that is 0.81. Okay. Right. Next question. If R is equal to 0.3, the coefficient of non-determination. The coefficient of non-determination is 1 minus R square. Okay. So 1 minus 0.09, it is 0.91. Okay. Our answer is option C. If R is equal to 0.3 and N is equal to 4, you should say whether R is significant or insignificant, okay, for which you should compute probable error of R. That is 0.6745 into 1 minus R square divided by square root of N. Okay, on substitution, I get 0.3069. Okay, here your R value is less than, R is less than probable error of R, which implies R is insignificant. Okay, I have given 3 rules in the beginning, right? If R is less than probable error of R, R is insignificant. If R is greater than 6 times probable error of R, it is significant. Okay, let us come to the next question. Probable error of R is given. Probable error of R is 0.6745 into 1 minus R square divided by square root of N, which implies 0.085 is equal to 1 minus R square divided by square root of 16. On solving, you get R square is equal to 0.4969, which again implies R is equal to 0.7042. Now, this R is it less than probable error of R? No, right? So you cannot say that R is insignificant. But when you calculate 6 times probable error of R, this R is greater than 6 times probable error of R. So you can say that R is significant. Okay, R is significant. Option 1 is the right answer. And for the previous question again, R is insignificant. Option 1 is the right answer. Now, if R is insignificant, which of the following is true? If R is insignificant, R is less than probable error of R. If R, so option A is the right answer. If R is significant, then which of the following is true? This is true. R is greater than 6 into probable error of R. Option D is true. Okay. Now, if R is equal to 0.7 and N is equal to 64, what is standard error of R? What is the formula for standard error of R? 1 minus R square divided by square root of N. Go for this calculation. You get the answer is 0.06375. You can check out, right? The answer is option A. Yes. 68.26% limits of population correlation coefficient means what? 1 sigma limit. Okay. So the 1 sigma limits are R plus or minus standard error of R. Right? Okay. 99.73% limits are also called as most probable limits, are 3 sigma limits. Okay. So the answer is R plus or minus 3 into probable error of, standard error of R, which is option 2. Okay. If R is equal to 0.4 and N is equal to 25, which of the following is true? R is equal to 0.4, N is equal to 25. So probable error of R is 0.6745 into 1 minus R square divided by square root of N. You substitute this, you get the answer is 0.1133. R here is greater than probable error of R. Okay. So, but if you compute 6 times probable error of R, you can find that R lies between this probable error of R and 6 times probable error of R. Okay. So, if this is the case, nothing can be said about R. Right. You calculate all these things and verify. Nothing can be said about R. Okay.